This modest brick building on Indiana Tech's Fort Wayne campus was built before Abraham Lincoln was president and has survived the uncertainties of time for over 150 years.
The first time I went into the building, back in the early 1980s, there really wasn't a whole lot of historic fabric visible on the inside. It was just lots and lots of modern, office spaces and conference spaces and things like that. So it's been a real challenge for them to actually do what you would call a restoration. They have maintained the exterior of the building, which is the important part. It's the part that says, hi, I'm really from this earlier time period. They're bringing back the grandeur of the fact that it was a large building, that really was the centerpiece of the early campus.
In its early days, the building had many different uses, but for most of its life, it has housed administrative offices.
It needed some attention. There was critical issues going on with the envelope of the building as far as the roof and the brick and the masonry.
You'll see the decay and just deterioration of the age of the building. It's had its issues with roof leaks over the years, and you'll see some of that damage in the ceiling, but the roof system is going to come off the building. We're going to put a new roof system on the building completely.
When I first came to the university, I had a group of my business office people who lived in one wing of this building. Their office was in one wing. It literally went downhill. So the building really was in disrepair.
The floors up here move all over the place from the settlement and the movement in this building, but we can't expect anything other than that from a building built in 1857, 150 years old.
An extensive renovation using state-of-the-art environmental design technology began in the fall of 2009. By the summer of 2010, Indiana Tech's historic administration building had been given a new lease on life in the 21st century.
If you look at it from a cost perspective, it probably costs more to do what they've done. But I'm okay with that because that's an asset that will just add on to the assets that are the campus, and they're all part of the ambiance and the reputation of the university, and that's a good investment.
We could have built a building that size for about 1/3 of what it's costing us to renovate and restore it. How many 1850 buildings do we have? We don't have any others on this campus, so we wanted to preserve it as it relates to Indiana Institute of Technology, as it relates to Concordia Lutheran Seminary and College, and what it can mean for the city as a showpiece as well.
In 1830, Indiana was still a wilderness frontier. Trails and rivers were the only transportation network. A plan to link Lake Erie with the Ohio River by a system of canals was developed, and in 1832, construction of the Wabash and Erie Canal began in Fort Wayne. Work on the canal attracted thousands to Indiana, including Marshall S. Wines and his wife Elizabeth. In 1835, Wines purchased land east of Fort Wayne on the site of the present Indiana Tech campus, an area still considered outside of town and very much in the country. He built an impressive house on the estate that became known as Woodlawn. Wines' job was to supervise construction on a portion of the canal that ran to the east of Fort Wayne. Marshall's wife, Elizabeth, was known for her great compassion for the canal workers. The construction conditions were brutal, and many of the laborers became ill. Hugh McCulloch, a family friend, recalled that when a malignant fever broke out among a large number of immigrants, some of whom were in his employ, Mrs. Wines devoted herself for weeks to care of the sick. In 1838, there was a critical shortage of German-speaking Lutheran ministers available to serve the growing number of German immigrants that were settling in the Midwest.
Fort Wayne was a town of around 1,500 members in 1838, and into this place, which was very, very rural, came a fellow by the name of Friedrich Conrad Dietrich Winnekin. He had come to meet the spiritual needs of Germans who were pouring into the Midwest to settle, first by the tens of thousands, then by the hundreds of thousands, and eventually by the millions. They didn't, however, bring pastors with them.
Riding on horseback from town to town, Wyneken was soon overwhelmed by the size of his wilderness ministry and asked the Lutheran Church for more pastors.
He immediately came to the conclusion he couldn't do this all by himself. There was just too many people to care for across too big a wilderness. So he began to write letters back to Germany appealing for candidates to come over. Since they did not come over in large enough numbers for his satisfaction, Wyneken, never being the kind of man that would be content to sit still, immediately began to train people in his own parsonage in Fort Wayne and Decatur for the ministry. And that really began the move towards a seminary.
In 1846, Wyneken accepted a pastoral call to Baltimore and was replaced by Dr. Wilhelm Seeler.
Seeler volunteered to begin a seminary here, and with the financial help in Germany, established Concordia Theological Seminary in the parsonage at St. Paul's and in a small rental property next door. The purpose behind the Fort Wayne Seminary was to produce pastors as quickly as possible. In the process of beginning work at St. Paul's, the numbers started to climb very rapidly, and it was decided that they needed to buy a separate property for the seminary. And that's where the property which Indiana Tech's current campus actually starts to enter the picture.
Elizabeth Wine's husband, Marshall, had died in 1842, and by 1849 she was prepared to sell their Woodlawn estate. Concordia Theological Seminary had outgrown its St. Paul's location and purchased the property.
Consisted of around 15 acres on the Maumee River, about a mile to the east of the city of Fort Wayne, which was still quite small. Everything was still on dirt roads, and it was quite a hike to get out to the campus.
In the 1850s, the Missouri Synod decided that it would offer German and English-speaking boys who were not preparing for the ministry the opportunity for a secondary education in a Christian environment.
They decided to found an English academy and locate it at the Fort Wayne campus. The trouble is that also the seminary was there, and a teacher's college or teacher's seminary had been relocated from Milwaukee to the Fort Wayne campus. Because there was now really no room for all of those students and professors, they decided that they would build what was to become the old administration building on the Indiana Tech campus. This building then would house the seminary, the English Academy, and the Teachers Seminary.
The new English Lutheran Academy building was dedicated on October 25, 1857. This building still stands today and would eventually become the home of Indiana Tech's Administrative Center. The English Academy was a financial failure and closed after only 1 year in operation. The Teachers Seminary continued to thrive on the Fort Wayne campus, and the building was used in a variety of ways.
It had many uses. It was dormitories, it was a library, classroom spaces, it was faculty residence. I believe it wasn't until Concordia College moved here that it primarily was used as an administration building.
In researching the administration building's history, Malloris became aware of rumors that the Underground Railroad might have used it as a station to help escaped slaves flee to freedom.
This is probably not true. There are reasons for believing that it might have been, but I think the evidence is overwhelmingly against that possibility. But interestingly, it's very likely that this campus at some point, or perhaps a number of points on the campus, did serve in that way.
In 1861, the Missouri Synod moved Concordia College from St. Louis to Fort Wayne. faculty and staff lived in the east and west wings of the administration building. The students lived in the central portion, where all the classrooms were also located.
At the time of the Civil War, it was found better to move the seminary and its older students down to Missouri, where they would be safe from the draft in Indiana. There was a great fear that a lot of the people recruited to be pastors would end up being Union soldiers shooting in a war in the South. At the same time, they feared for the high school and college students who were younger that were on the battlefront for all intents and purposes in Missouri. So they moved them to the campus at Fort Wayne, where they joined the teachers' seminary, which was still there. They occupied the campus for roughly 100 years.
Because of crowded conditions, the teachers' seminary was eventually relocated to Illinois. Concordia College was the sole inhabitant of the Fort Wayne campus until 1935, when Concordia Lutheran High School began classes in Hanser Hall. Indiana Tech was founded in 1930 as Indiana Technical College. The school first leased and then purchased a former mortuary building located on East Washington Boulevard across from the YMCA, where many of the students lived. The first classes, held in the summer of 1931, had just 8 students. By fall, there were 139, and the winter semester enrolled 179 students. In 24 months, a male student could obtain a Bachelor of Science degree in electrical, structural, civil, or radio engineering.
Several entrepreneurs who had been in industry as well as in education started this school because of the heavy manufacturing that was beginning to develop in this area of the country. Engineers were needed, hence Indiana Tech became an engineering college for men back in the 30s. By the 40s, with the war, the enrollments had declined significantly. However, when the war was over and the GIs came back, many men were coming back to college at that time. And of course, Indiana Tech began to grow into the 50s and then bought the campus that we're on today, where Concordia Lutheran Seminary once was housed. So in the mid-50s, we came to this campus. And of course, since the 50s, we've expanded the campus. We've grown in terms of the programs. We're not just an engineering college any longer. And the rest is kind of history, as they say.
After purchasing the campus from Concordia College in 1953, Indiana Tech officially moved to its current location on July 1st, 1957. By then, enrollment had reached nearly 2,000 full-time students. Many, like Robert Gill, a 1960 graduate, were military veterans.
All of the students here were GIs. This was an accelerated program where you went 27 months straight through, winter, summer, no breaks. And it was very, very concentrated technology. I had one English class, one technical writing class, and all the rest were math, science, and engineering.
Challenge. The mystery of the great unknown is being explored unendingly by American engineers, hoping to find practical application for improvements in all of our lives and ways.
One of the very early things it taught me was, in the Navy I had a year of training in electronics, but it was to repair the equipment. Now I was getting the education of how to create it and design it and build it.
With each new challenge, always the call goes out. Help wanted.
Help wanted. Forward-looking men and women, eager in outlook, with vision, perspective, honest point of view, to see the challenge of our times. Men and women boldly imaginative, of character, of penetrating curiosity, and of barrier-breaking courage, to engineer the freedoms of American future.
The fact that I knew how much I enjoyed learning, how valuable it was, and how I still today love to learn. And that came specifically from that education here at Tech. When you look around the campus today, one of the things that's hugely different is there's many more students on campus. There's many more facilities, because we had a cafeteria and we had a gym, that basketball gym, and that was really about the only sport that was very active here. And there was hardly any intramural sports. And so there was not the, quote, campus life as you would normally think of it back then. But most of us were GIs that weren't interested in that. We were here for a very specific purpose, to get an accelerated education as rapidly as we could to go out and make a living.
In the 1960s, the school's name was changed from Indiana Technical College to Indiana Institute of Technology. It also began offering 4-year degree programs. Ron Kantorek came to Indiana Tech in 1966 and was a student in the aerospace engineering program for 3 years before changing his major to mechanical engineering. Kantorek decided that mechanical engineering would give him more employment opportunities.
With a mechanical engineering degree, I basically could work anywhere for any company. The campus itself, from my view, was significantly different in a couple of ways. First of all, the buildings. Almost entirely all of these buildings that are on the campus today are new structures compared to what it was like in 1966. And in addition to the change in the buildings itself, the makeup of the student body is significantly different also. At the time that I went here, it was purely engineering and science. That was the only curriculum that was offered in Indiana Tech, and all of the student body was all male. I mean, I can remember there might have been a few girls, 2 or 3, but that was about it during that time frame.
Indiana Tech's historic administration building, dedicated in 1857, is the oldest building in Fort Wayne still being used for its original purpose: education.
The building that has stood on that campus ever since the day, that they began teaching there, that building remains. So that piece of history is still relevant. The challenge for every college campus really should be to look at what are your historic structures and how can you continue to use them and utilize them. Update the interiors as you need to. Make sure that you can use your internet and your Wi-Fi and have your phone systems in. But bring it with you into the next 50 years or the next century.
One of the key issues, though, is the fact that we've already bulldozed all the other old buildings down. And the history of this east central part of our city would constitute this building as one of the original buildings. In fact, one of the original buildings in the city, for that matter. So we wanted to preserve it for that reason.
Dr. Snyder would come into my office. Every time he came into my building, he said, "This building smells. It smells in here." And I said, "I don't smell it, I'm used to it." You get used to what you live in all of the time. So he really was the driver for moving the project forward. He finally came over enough and said, "We need to do something with this. This is a building that means something to our alum."
You need to have some connection to the history, to the tradition of the school around for alumni like myself. It helps maintain a connection to things the way they were like when I was here and others were here. And I think that that's important. It's not merely the fact that this is on the same property, where we went to school years ago, as much as that there's some tangible thing that you can look at, that you can see, that you can relate to when you win here too.
It had several different, what I would call, remodels done to it. Some of them not done very well. The heating and cooling system had been replaced in the last 10 years. It went from an old steam type heat system to a gas forced air with air conditioning in it. It was overdue. The university over the years had chosen to renovate some of their older facilities, but a lot of them through the times had just been demolished, and they no longer existed. So the university felt it was really important for alumni to that came back to see that, hey, there is something they recognize, because a lot of times we'd hear that they didn't even recognize the university any longer. So it was really a focus of us to save one of the really old buildings that everybody did recognize.
The U.S. Environmental Protection Agency defines a sustainable or green building as one that is environmentally responsible and resource efficient throughout the life of the structure.
As we began to evolve in our thinking, we had initiated an energy engineering degree several years previously. We said, boy, wouldn't it be interesting if we could make this a sustainable building in a number of different ways? Maybe the first in Indiana that's 150 years old that we're bringing up to some standard of LEED silver status. So we began to integrate different ideas.
The Leadership in Energy and Environmental Design, or LEED, Green Building Rating System is an internationally recognized certification system providing a set of standards for environmentally sustainable design, construction, operations, and maintenance solutions. A LEED building is one of the highest honors a building designer and owner can achieve.
It's a third-party proof that we're doing what we say we're doing. People say that we're green or we're sustainable. The LEED stamp of approval says, here's how they did it, here's the proof to back it up.
We will be going through every piece of equipment with the control contractor and checking calibration of sensors, checking the operation, heating, cooling, wintertime, dehumidification. We run the units through their paces and basically try to break them and see if they work. Basically, we want to verify that things work.
The green renovation was also a perfect fit for Indiana Tech's Bachelor of Science degree in Energy Engineering.
We felt very strongly the right thing to do is to save the building, restore an old historic building, make the outside look very much like its original condition, then completely gut the inside to make the inside very modern, very friendly for administration, for students, for visitors. And then we've incorporated a high-tech geothermal system. For me, this is just the perfect kind of engineering project that the students can say, I can upgrade a system, I can add new technology to brand new systems, or I can renovate something very old. So this is really an exciting project for Indiana Tech and our community.
I had already had a lot of hands-on experience because of my experience in the Navy. But I have to say that I learned as much in the labs here as I did in all of the time I did in the Navy as a repairman. And those lab experiments and the lab teaching that goes with it and the rigor and the writing of the report and all of the things that go along with that are just invaluable to a student. Now when you apply that to one of the newest technology things around, this geothermal field, I bet there's not 5 labs in the country right now that can give students that sort of hands-on touch, feel, understanding.
It's history here on the campus, and I know that they wanted to keep the oldest building here on campus, and so switching it over to a geothermal system and then being able to still say it's the oldest building is really neat. You can read all about it, but getting the hands-on experience is really going to be useful and helpful later on after I graduate. When we came up with this idea that we wanted to make this building
LEED Silver rated and be friendly and sustainable. We also thought about how much that might cost us to do that. So we were looking for opportunities to get some help, and we felt that if we were going to take an 1850s building and bring it up to that standard, that the Department of Energy or other sources might be interested in that. So we did bring a proposal to bear and sent it into the Department of Energy, specifically asking for help with the geothermal system, which is a very costly item. And we received approval for a $1.34 million grant from the feds, which we will have to match with our institutional funds.
Indiana Tech's funding proposal to the Department of Energy included a partnership with Fort Wayne-based geothermal manufacturer Water Furnace International.
Water Furnace was originally founded here in Fort Wayne. It started off as a distributorship for a brand of water source equipment that was out in the market. The founders quickly became unhappy with the performance of that equipment and realized that the only way that they're going to make a dent in the market was to produce their own equipment. So a line of equipment became available from a competitive company in 1985. The investors bought that line of equipment, moved it here, and set up shop in 1985 as what we call an original equipment manufacturer. Started assembling product in late 1985 and in early 1986. Since then, the company has grown from essentially 3 employees in the early days to over 280 people. We've grown from roughly a few $100,000 in sales to over $130 million in sales.
In addition to the Department of Energy matching funds, Indiana Tech received a $2 million contribution from 1951 alum Wilford Utangsu Sr. Indiana Tech will acknowledge his generosity by naming the renovated administration building the Wilford Utangsu Sr. Center.
Mr. Utangsu, who is a Filipino by birth, first went to school at Stanford University in California and read of the chemical engineering degree here at Indiana Tech, got his degree at Stanford and came to Fort Wayne, Indiana to get another engineering degree in chemical engineering here at Indiana Institute of Technology. So he's very proud of what he accomplished in his career, and he's been philanthropic and willing to give back, and we're very blessed to have him as an alum.
Mr. Utangsu unexpectedly passed away in April 2010. He is survived by his wife and 3 children.
He was a very, very good man, and he was a very humble man. I think he was the most humble person that I have ever met. I feel very fortunate that he did come into my life because he made a difference in my life. He certainly made a difference in a lot of people's lives.
The magnitude of the work that has gone into here is nothing short of phenomenal. So seeing the transformation from a pre-Civil War building to what it is today is outstanding. It's a great display of engineering and preservation of heritage architecture. So we're very honored to be associated with the center and with Indiana Tech, and I think it's a great example for the students to get to see 21st century green technology in action right in their own school.
Today, if you can find an area of interest that truly excites you, and it's hard as a young student not knowing exactly what you want to be, but in my father's case, he knew right away the goals he had in life and what he wanted to do in terms of making his mark. And if I could just offer to students at Indiana Tech, if they can find their passion, and you have a wonderful engineering program here, as well as many other programs today. So success is something that you can define for yourself, but it starts with passion. And if you have that, I think the road to success becomes much easier.
Right now I'm standing in the core of the building. We reference this building by the core and the east and west wing. It's 3 portions. I'm standing at what is the current basement or crawl space door, and down there is the dungeon or the basement, and we're going to actually renovate that space. It is about a 4.5 foot tall crawl space or basement right now. Load-bearing brick walls and cobblestone or fieldstone foundation walls, going down to what is actually a brick floor system. And then there's crawl space throughout the rest of it with dirt floor, and you can see deteriorated brick from over the years. Been a lot of moisture issues down there. There you can see there are jacks actually holding up the old wood floor system that we're standing on because it's unlevel, it's dipping, it's deflected, it's moved a lot over the years. But we're going to take that old wood and salvage it, so that's a good thing. And that brick that I talked about in those load-bearing walls, we're no longer going to load the new building to those walls, so we're going to salvage that brick and reuse it. A little dark and dingy down there now, but when we get finished, it'll be like a new space.
Last fall, we started on the east side of the building, and the biggest hurdle there was we had to install a basement underneath that site, which was a challenge in itself. We had to dig about 3 feet of dirt out from underneath there, and you know, the old foundations are stone, mortared stone, so there really are no structural properties you can calculate. We had mechanical equipment, electrical, elevator equipment room that had to go in that space without adding on to the building. And if you actually walked in there when we had the hole dug and looked up, you could see all the way to the roof line. All the floors had been removed, so it was a challenge, and it was a bit scary, but we took the precautions and handled those accordingly.
Everyone involved spent quite a bit of time in this building documenting what they could see, and that required a lot of crawling around in dark and wet places and in a lot of attic spaces as well. Because the building is so old, there was a tremendous amount of field work and investigation required to understand the state of the state, so to speak. Physically, how, you know, the condition of the existing building, how stable were the existing foundations, you know, distances between point A and point B. Those dimensions are certainly very critical for things like ordering steel to correct dimensions and so on before it's installed here on the site.
Now keep in mind the exterior walls, which are solid brick, three wise wide for the first level, and then once you get up to the second level, it's only 2 wise wide. Again, the structural properties there of a brick we know today, but after 150 years of weathering and having water or humidity, the properties change. They become softer, and that was probably our biggest challenge. You know, we were hugely concerned about taking out the floors and making sure we properly shored them so nothing would, you know, obviously nothing would collapse. Because if you actually rewound this thing and you've seen how they built it, which at the time when I was doing the pre-construction I had a decent idea, but once we did start pulling things apart, you could see it. You build a wall to the first level, they set the floor, which was all timber, and then they build the second set, you know, the walls to the second level, and then they set the floors. And then they went to the roof and they set the roof. So as they went up, they were structurally supporting the floors. That's how it was built. Ideally, you want to take it down the same way, but in our case, the wall stayed. So as you take the floors out, you're taking out the support for the walls themselves. And we couldn't anchor into the brick, we had to anchor through the brick just because of they were so soft. So to support it, we actually made it rigid enough so we could put the new steel in place until we tied that back off to the building. Once we got the roofs back on, at that point our risk was minimized, and at that point it was just a matter of, you know, finishes and putting mechanical systems in place to create the space it is today.
In here there's going to be some historical cases that have some historical information in it, maybe items that they've saved from the buildings, and they're all made out of that same reclaimed wood. So we're using a lot of the ash that was reclaimed for the facility.
I remember those old hardwood floors. They were something else. In the old school building, Seiler, was that the name of it?
Seiler and Schick.
Schick, in Schick Hall. When you walk through the building, the floors would creak, and it was the wood that did that. So you're going to make window frames and other cabinets and things out of that.
Yeah.
That's great.
Yeah, that's great.
So you've got heat pumps located, smaller heat pumps,
Correct.
located throughout. Good. See, then I learned something by coming here today. Well, I think it's coming along really great. There's a lot of impressive things that I've seen integrated into this building, and particularly because it's a challenge of renovating an old building, basically building a new building inside of an old one. And there's all kinds of challenges associated with doing something like that. And I'm really impressed with what the guys are doing here, particularly with respect to the geothermal systems that are being put in. It's good to see this stuff happen.
Geothermal technology takes advantage of the Earth's relatively constant temperature to heat and cool a building. There are different types of geothermal systems, but Indiana Tech's administration building will use a vertical closed looped system. For a vertical system, well drilling equipment bores small holes, approximately 4 inches in diameter and about 20 feet apart, to a depth of 100 to 400 feet. 2 pipes are placed into the holes and are connected at the bottom with a U-bend to form a loop. The vertical loops are connected with horizontal pipe placed in trenches. When water is pumped through the wells, it transfers heat to or from the building, regardless of the outdoor temperature. For heating, a geothermal heat pump removes the heat from the water, concentrates it, and then transfers it to the building. For cooling, the process is reversed. Conventional ductwork is used to distribute heated or cooled air from the heat pumps throughout the building. The administration building has a total of 9 heat pumps, with approximately 3 per floor.
When you couple a heat pump with a geothermal loop, what you're doing is you're connecting it to a ground source for that geo connection. And in this case, we have vertical wells drilled down outside the building to a depth of 450 feet, and we're circulating water down through those wells. It's a closed loop system. So we're pushing the water down and pulling it back up. And by doing so, the ground temperature stays fairly consistent down in those depths, and so we're able to use a very consistent ground source to provide a cooling source for the building and also a heating source. And with the heat pump technology, even though it's a 50-degree ground temperature, we can use that and make heat using heat pumps very easily.
Well, the geothermal field that we talked about basically is what serves the heating and the cooling for this building. And it's buried in the ground behind us here with a series of vertical wells that are 400 feet deep, with piping that runs down each well and back into the building. And that piping comes in contact with the ground and provides a heat source in the winter and a cooling source in the summertime. This is a space that did not exist in the building originally, back when it was built in the 1850s. It's new space that we dug underneath the old building, and it's where we house all the mechanical systems for the geothermal system, the plumbing systems, and the electrical systems. And what we have over here behind the electrical panels are the pumps that drive the geothermal system, and this is what moves the water from the wells in the ground up through the building to each of the heat pumps. And each of the pumps has what we call a variable speed drive to change the speed of the pump, and that's used to optimize energy performance on the pump itself. And when we don't have need in the building, the pumps will slow down automatically based on that need. And then above that, we have our energy monitoring panel in the black box, and that's what will collect a lot of the data for our energy consumption coming on the electrical service. That'll measure all the consumption in real time and report that to our building control system. Well, what we have here is one of our heat pumps from Water Furnace. This is the unit that has the extra instrumentation that will feed a lot of additional data to the building control system that we're going to collect as far as its performance on our energy standpoint, our refrigeration cycle standpoint, and how it operates in very specific detail. And all of this data is going to get collected and archived out for student access, and they're going to be able to use this data to compare it with their laboratory experiments and their classwork to determine if what they're studying in the academic world actually correlates to the physical world, that real use, real equipment operating in the real world. And a lot of the instrumentation is buried in the panels here that are open at this point, but the students will have access to come down and kind of take the doors out this particular unit and see how it all works and learn about the HVAC equipment in the building.
We'll look at the entire building, heat losses out of the building, and energy that we're putting in the building. So in effect, we will create a conservation of energy model for the entire administration center. That's one excellent long-term project. Some students will want to study the behavior of the ground loop. That loop in itself will be a very good learning opportunity for students. So students, if they choose, can specialize in that portion of the project. Probably a third very, very good long-term project is studying the behavior of one heat pump. The traditional compressor, condenser, expansion valve, and evaporator. How can we improve that system? So immediately I can see several very good long-term projects.
I think it's a wonderful opportunity. I look back to my time in school, and we spent a lot of time in laboratory and simulating things and doing our book work and our coursework, but to actually have a real-life example that isn't a theorized or idealized model to look at to see, does it match with the calculations, and where are the inconsistencies. It's a huge benefit to the student. I would have loved to have had that opportunity myself.
This is the primary hallway that connects these two entryways. Well, along this wall, what we're going to do is have flat panel monitors that show how the building is operating.
Here in the entry hallway, we're going to have two large flat panel screens that are displayed, and primary function is to show the public what's going on with the building from an energy standpoint. We're going to track in real time what current weather conditions are outside using a weather station up on the roof. Then we're also going to show the energy consumption of all the heating and the cooling equipment, the water consumption of the building, and the electrical consumption of many different aspects between the lighting, just the general plug use of computers and refrigerators and copy machines, and then break that out into the heating and the cooling. And we're going to trend that data every day, every month, every year, and we're going to show in real time what they're consuming, what they consumed last month, what they consumed the prior year, so you can kind of see the trend of the building and how it actually functions.
The original building actually had quite a few load-bearing brick walls interior to hold up itself and the roof system. As part of the renovation, we took out all of that interior structure because the new building actually has steel and concrete structure as far as floor systems. So we salvaged that brick. So the brick column here on the entryways, all that's original brick that was from the interior. We just put it on the exterior out here, tried to match the mortar best we could, and over time that'll blend in with the rest of the building and no one will ever know it wasn't there.
Right about where I'm standing will be, over in this corner, right in here will be the new fireplace built from that salvaged brick. So that's going to be the thing that draws you to this space as you come through that door.
Quite often when I come in here and show people around the building, he said, well, this was always here, this is great. And I said, no, it's all brand new. This is a reclaimed brick, as I said, from the interior load-bearing walls of the building. We did put this coining in here to dress it up a little bit and tie into the limestone on the exterior of the building. But this mantle, for instance, and the wood trim you'll see around the room on the windows and doors, the display cases, this is all reclaimed wood, salvaged wood from the original building. The original building was all wood floor systems and wood structure. So we took that old material and with a lot of hard work from the casework guys, they were able to basically mill the wood down to the shapes and sizes and style we wanted, and then finish it. What we did is we took the finished color of the doors from the factory, matched that, and stained everything in the building to that color. And then these display cases, all the wood in these display cases is salvaged material. The school's going to use these display cases for showing Actually, their history as well as Concordia's history, last October when we were up here, this was unused space, totally unused space. They hadn't been using it for years. It had old tile, it had water damage, it was pretty rough. So this has been a great transformation. Actually, the people moving up here, the president and the VPs from the school, but this piece of stained glass, this was not in the design originally. Throughout this process, some of the folks here on campus had heard about a gentleman that had purchased a bunch of stained glass out of the original chapel, which was here on campus as part of Concordia's campus. That was, we believe, from what I've been told, has been torn down in the 1980s. And the school found out about it, visited that with that gentleman, and actually was able to purchase this and have it restored. What we did was we played off of those arched windows from downstairs and brought that up here. So this actually is a borrowed light that goes over into the president, Dr. Snyder's office, and we'll go on in here into his conference room. All the casework cabinets, all of the wainscoting and wood trim you see, and actually even this is a credenza to hide a TV in. All this is reclaimed wood from the original building. The flooring we're on, this is actual hardwood tongue and groove flooring from the original building. We had it milled down, had it recut, and put it in and restained it. The great part was local Habitat for Humanity or Restore took all the windows, took all the doors, took all the door hardware, took all the stuff that actually got salvaged from the building, and cabinets and sinks and faucets and other things, and they salvaged that material and saved it, and hopefully someone got to reuse it on another project. But to know that we salvaged wood, we salvaged brick, we didn't just throw it in the landfill. I know that we're actually over 80% on our construction waste management plan, that 80% of the material from the demolition and new construction of this building was diverted from the landfill. So that's a lot of landfill material that got reused or recycled or turned into something else. Locally, this will probably be the second LEED certified building in the area, and the difference is that's a new building, this is a 150-year-old building. So we can prove we can do it to an old building like this. And if anybody can do it to an old building like this, then it shouldn't be a question anymore that we've proved ourselves, and hopefully others will come here, see what we've done, and want to do the same thing.
The Administration Center is the first Indiana Tech building to be heated and cooled using geothermal technology, but it will not be the last. The school has plans to retrofit additional campus buildings with geothermal technology. A second vertical well field and experimental community earth loop system are being installed under the parking lot of the Cunningham building to support future geothermal expansion.
At Indiana Tech, they're doing an innovative design from the standpoint of how the earth loop is being applied in a commercial application. They're using what's called a community or a district loop system, which would mean that several buildings are going to share that loop. What is much more common in this country is to have one loop for a building or a residence. So what we plan to demonstrate is that a loop that is common can be used very effectively by two different buildings with two different loads with different types of equipment.
In this particular job, we're drilling 40 holes, 400 feet deep, and we're installing an 1.25-inch loop in each hole and grouting them when we're done. The drill stem is in 20-foot legs, so you drill down 20 feet and you unscrew the top head and pull her up and add on another 20 feet, and you keep going down in 20-foot sections till you get to the bottom. All in all, one bit will do a hole. You use one bit to do a hole 400 feet deep, but it takes anywhere from 9 to 12 and a half hours to do a hole.
The pump house is the central location for circulating water throughout the community ground loop. It's also where different sections of the geothermal well field will be controlled. The field is sectioned off into several zones, allowing circuits of wells to match the energy loads of different buildings. Fewer wells can be used for smaller heating and cooling needs. When the energy demand is greater, additional wells can be brought online to support the increased load.
From out here at Cunningham building, the parking lot at Cunningham building, we're going to directional drill actually 10 lines, 2 groups of 5 of 3-inch lines to feed this geothermal field up to the pump house is what we're doing. And the pump house is just on the west side of the baseball field over here. So we're going to actually be drilling a line underneath and pulling all these lines back so we don't disturb all these buried utilities. There's a 100-year storm sewer here. There's fiber optic lines, gas lines, etc.
We were looking for someone who would be strong in helping us on the geothermal side, and who else than right here, their headquarters here in Fort Wayne, being Water Furnace. So bringing them in as a team member, it wasn't just about, well, what do you have on the shelf? It's what can you do that's going to come out down the road that we can maybe integrate into this building or another building here on campus to show that we can do even better. And they came to the table with some technology that they're still working through the details of. We hope to install it in the Zollner Engineering Building here in the next couple months. And it could change the way we do things on the HVAC side of, and it'll be interesting to see how it performs. And they wanted to use it as a prototype, that building as a plug and play. You can plug it in today. Okay, here's how it's performing. Well, if they build a new model, we can take that one out and plug it in and see how it performs. So the Zollner Engineering Building becomes a working tool for geothermal.
One of the heat pump systems that will be in the Zollner Engineering Center will use CO2 as refrigerant. That technology has not been used very much at all in the United States. It's really a high-tech or an experimental technology. We don't know how well the system will work.
With the demonstration of this technology, we hope to show that we can heat water to higher temperatures than the current refrigerants. We also want to demonstrate the reliability of equipment, maybe of a little bit larger size than what's commonly available.
We'll be experimenting with a new technology, and the students will help monitor the performance. And we'll be working with water furnace engineers, the designers of the system, and helping evaluate how well that system works. That will have the temperature and pressure sensors too. So we'll be able to run it through all kinds of operating rooms. I'm looking forward to that.
Yeah, sounds neat.
Yeah. So this is real exciting for me. It's a technology I can't find data for in the United States.
And we hope that these 2 demonstrations of equipment will provide the students a good opportunity to learn, take notes, take data, and just provide a good experience and hopefully train some people to be very competent coming into the geothermal, shall we say, field after graduation. It could lead to hopefully some employment, possibly with Water Furnace or with somebody else in the field that would have some benefit to the whole industry as a whole.
It looks somewhat familiar, but like not really.
Yeah, well, a refrigerator or an air conditioner or a heat pump, they work, the fundamentals are the same. We're really on the cutting edge where our students will be able to contribute to the investigations water furnace engineers are making. And my students could make a difference in making these systems available to consumers in the future. That's very powerful.
I can say with gratitude and confidence that the Wu-Tang-Su Center will stand for many centuries and serve this university campus for many, many generations to come. My friendship with Mr. Fred was brief, but it was very significant to me. His legacy is not just a name on the building. His legacy is the example he has set for his children, his grandchildren, and all of those that crossed his path.
He would have watched all of the construction that he could have. He would have loved it, and he would love the final product. We were very, very impressed. The engineers here, the planning that went into this. This is the kind of person he was. He didn't want to do anything unless it was done the right way. And this certainly has been done the right way. He would have been very proud.
It's true that I didn't always know what I was going to do with my life. I wasn't a born leader, but I knew I wanted to be one. Once I understood that, there was really only one university for me, Indiana Tech. You see, people attend Indiana Tech to become leaders in the fields of business and engineering, criminal justice and communication, web design, and elementary education. Me, I'm studying accounting. You can learn at any university. At Indiana Tech, you can learn to be a leader. Indiana Tech. Live, learn, lead.